So last day we have discussed one type of cyber attack in terms of sock puppets and puppet masters. So today we will discuss another application, another again cyber security related applications, and today we will see how to identify collusive activities in online social network. So let me start by telling you a story, and this is really that this is useful to motivate the problem. So when I joined IIIT in 2017, I was given a responsibility of promoting a workshop. So IIIT started thinking of organizing a workshop, and I was new, so I was given the responsibility of promoting the workshop on social network. And that time I was not that social media savvy, so I just wrote a simple post about the workshop on Twitter, assuming that since this is about a scientific event, it would automatically attract audience. Okay, but unfortunately, in 3 days, right, my post received only 5 retweets. Okay, I thought this should not have happened, because this is ultimately about a scientific scientific event, so it should automatically attract researchers, students, faculties, practitioners working in social network. The fun fact was that that time in my lab there were around 37 students, BTech, MTech, PhD, RAs, right. In fact, they also did not care about retweeting my tweets, right. So you all agree that publicity is really hard, okay, and when it comes to organic publicity, right, you really need a reach, right, a wide reach, a reach, so that people can just look at your tweet and just automatically retweet it, right. But nevertheless, I knew the secret, because I was working on analyzing the collusive activities in online social network, and I just applied the tricks, and look what happened after after 30 minutes. So within 30 minutes my tweet got boosted by 70 retweets and 10 likes. Okay, and this happened just within 30 minutes of applying my tricks. Okay, so you may wonder what is the trick. So before that, before revealing the trick, let me also tell you some other news events, news article stories that were quite popular. You may have heard about this story, right, by one of the socialists in the UK, Louis Minch. So Louis Minch account, right, got a significant number of retweets, a significant number of followers within a very short period of time. Within only 24 hours, this person got around 80K followers, right, 97% boost, and that too within one day. So of course people started shouting that how it happened, right. People did not have response, people did not have enough justification behind it. You may have heard about some Italian professors. He actually had doubt about politicians Twitter and their followers. So he claimed that majority of the followers of leading politicians are essentially fraud followers, fake followers, right. Fake tweets, fake Twitter account for newly appointed minister received thousands of followers. So these kind of news articles are quite prevalent across social networks, right. You may have heard about such news events in the past, right. So if you wonder, right, what actually makes all these accounts popular within such a small period of time, and that too in such a way that the Twitter will not be able to identify, to detect such such activities, right. Here is the solution. So, on social media there are multiple such black market services, right. These black market services are open, they openly promote their services, right. What they do, say if you want to boost your tweet, for example, boost your follower, boost your Twitter account, if you want to boost your YouTube video, if you want to boost your Facebook profile, right, you just contact these black market services and they will give you the service, right. So, services like there are multiple such black market services publicly available, like for like, just retweet, you like hits, they view me. These are all different types of black market services which provide you with retweets, follows, views, likes and whatnot. Okay. So, if you look at the way they operate, right, there are two modes of operations. The first one is called freemium service. Now, so the default is premium service. So, premium service is very simple. You go, you basically approach them and you tell them your desire, your event, right. They will charge you lump sum, okay. And this is really lump sum, okay. I mean, I have tried it for my research, so you can also try it out, although it is not recommended as such. They charge lump sum, but if you do not have money, you still can opt for their services, right, by opting for this freemium service. Now, what does it mean? So, freemium services are essentially unpaid services, right. Say for example, you want to boost your tweet, right, you contact them, and what they would do, they would take control of your account, of your Twitter account. So, your Twitter account will be compromised for a certain period of time, right, and your Twitter account will be used by them to do all such crap activities, followers, retweets, following others, retweeting others' tweets and so on, and through these activities your account will gain virtual credits, right, and then you can use these virtual credits to promote your own event, right. So, your account will be compromised for a certain duration, for say 3 days, 4 days of duration. When you get significant coins, significant virtual credits, you can then use this to and then your again account, you will get control of your account and you can use your this virtual credits to boost your post, right. So, the interesting part about the freemium services is that the normal customer like us, right, they become the part of the black market services at a particular time period, right. So, in general, since we are normal customers, our behavior is quite organic, right, but for a limited period of time our behavior becomes inorganic when our account is controlled by the black market services, right. So, it is very difficult to identify freemium activities because the customer, right, genuine customers like us, they become part of the black market services and start doing all these inorganic activities at certain point, and then after that they again they are free and they start doing organic activities. So, you see a mix of organic and inorganic activities exhibited by, right, these freemium customers. So, our research is focused on our research completely focuses on freemium services, right. In fact, the topic that I am going to cover today is basically a part of our research, our lab's research. So, now this is totally against the terms and conditions of Twitter, right, because Twitter strictly said that if so the question is, can I purchase or sell account interactions, right, on Twitter, and the answer is no. Twitter strictly prohibits the purchasing and selling of account interactions on our platform, right. So, this is against the terms and conditions of Twitter, right. So this is kind of a harmful activities, because ultimately you are boosting your tweets or your events based on some inorganic activities, and your boosted tweets would further influence somebody else to do some other activities, right. Now think of this tweet that you are boosting is a hate speech, right. Then this hate speech starts propagating, right, massively, and people may get provoked, right, by this hate speech, and then that may lead to communal violence and whatnot. Okay. So if you look at the state of the art, right, studies for say bot detection, fake account detection, fake activity detection, most of the cases what people claimed that there is a synchronicity, right, in terms of there is a synchronicity in terms of the time these activities happen, right, the set of users that these fraud users follow, the the kind of posts that these fraud users write. So these things are more or less same. They tend to write similar kind of posts, they tend to follow others around the same time, they tend to follow same types of users, right. So most of the existing studies claim that fraud activities are synchronous in nature, okay. But we showed in our research that collusive activities are asynchronous, and that is very obvious, because there is no synchronicity between my activity and say your activity. Both of our accounts say have been compromised. My account has been compromised in one point, your account has been compromised by another in another time, right. But there is no synchronicity, right, there is no time synchronicity. If you think about sock puppets, right, sock puppet activities are synchronous, therefore we consider the time duration, hopefully you remember, right, the time duration as one of the signals to capture sock puppet activities. So so here we claim that collusive activities are asynchronous in nature, therefore we also showed empirically that state of the art methods for detecting fraud activities are not useful for collusive activity detection, okay. So for that what we proposed a method called CoReRank, CoReRank, right, which is an unsupervised approach for collusive activity detection, okay. So let us look at this CoReRank algorithm. So this was proposed by my team, right, in 2019, published in WSDM conference. So what it does, it first creates a bipartite network, user post bipartite network, right. So from the bipartite network, it measures two quantity. One is called the credibility of a user, other is called the merit of a tweet. I will discuss what do you mean by this. I'm just trying to give you the overview of the algorithm. So from the bipartite network, we measure the credibility of the user and the merit of a tweet, and in some ways we basically employ an iterative approach. This is unsupervised. So behavioral based iterative approach to measure the credibility and the merit, right. And then we said that okay, so users with less credibility are collusive users, and tweets with less merit values are basically fraud tweets, okay. So we created a bipartite network, right. So in order to create the bipartite network, we basically define something called the degree of support, right. So user can support a tweet in two ways: by retweeting. So retweeting is a direct citation of the tweet, right, or by quoting. Quoting means you retweet with some additional text, right. In this way we basically support a tweet. Just to again reiterate, what is the problem statement here? The problem statement here is to detect collusive retweeters, okay, from Twitter. So, right. So, we basically define two quantities. This WQ is the amount of support due to quoting something, and WR is the amount of support due to retweeting something. So, WQ is greater than greater than WR, because when you quote something, right, you basically add your own opinion, and that is actually better than just retweeting something. So, whatever value we choose later, we need to make sure that this satisfies. In fact, it should be like this. Okay. Okay. So now now we create a bipartite network. So in a bipartite network, what are the users? So users are, some users are taken from black markets, some users are normal users, and so on. Now remember, this is a unsupervised method. So the identity of a user, whether the user is a part of a black market service or not, this is completely flagged in our algorithm. So the algorithm doesn't know which user is part of which part of black market services, right. So we have some black market users, we have some normal users, we have some verified users, we have their followers, followees, and so on, right, and that constitutes the user set, right, and the tweets that they retweeted within a particular period of time, when we basically scraped the data, that constituted the tweet partition. So we have user partition and tweet partition, and then you have basically two kinds of edges, right. One is a retweeted edge, other is a quote edge. So these bold lines are quoted edges, and the thin lines are retweet edges, right, and we have WQ weight and WR weight, right. Then we propose something called the credibility of a user. So the credibility of a user U, denoted by CU, is essentially the, so we, let me also tell you that we also propose something called the merit of a tweet, right. So the credibility of a user is determined by the number of meritorious tweets the user has retweeted so far, right. How do we quantify merit? We will discuss, right, where similarly merit of a tweet is determined by the number of credible users who have retweeted the tweet or quoted the tweet, right. So you see that credibility and merit are basically interlinked, okay. So we will see how to compute credibility and merit. Then we look at an important quantity, which is the inter support time, right. So the inter support time for a user, so what we did, for every user we basically noted down the tweets T1, T2, T3, right. These are the tweets that this user retweeted, right, and you also know the time when this retweets happened, right. So for every consecutive retweets, we can identify the time difference, right. So T1, T2, T3, and so on and so forth, and then, right. So IST is the inter support time. Inter support time is basically the time duration between two consecutive retweets, right. Say 4 minute, right, 10 minutes, 24 minutes and so on. This is basically a set, right. So then we came up with some axioms, right. So the first axiom was collusive users have very less inter-support times compared to genuine users, meaning that collusive users basically retweets, they retweet in a very quick manner, in a very short duration, right. See the plot here, x axis is the time of retweeting, this IST, inter-support time, and y axis is the number of such cases, right, and this black line indicates the collusive behavior and red line indicates the genuine behavior, right. You see that there is a peak for a collusive user, is a peak, right, at the minute granularity, right. It means that the average inter-support time for collusive users is mostly in terms of minutes, whereas for genuine users the peak is here, days and months, right. So this was the first axiom, right. Then we also observed that if you take two tweets T1 and T2, we basically quantify something called identically collusive support, right. What does it mean? It means that there are two tweets T1 and T2 retweeted by U1 and U2, right, such that the credibility of U1 and the credibility of U1I and U2I. So U1I is the retweeter of the tweet T1 and U2I is the retweeter of the tweet T2. So if the credibility of these two retweeters U1I and U2I is same, then we say that okay, T1 and T2 are supported by identically collusive users, right. They are different users, but their collusive nature, their credibility nature is same, okay. So axiom 2 is basically saying that among tweets with identically collusive support, a highly meritorious tweet receives higher support, right. You see two tweets T1 and T2, although they are supported by same credible users, but if T1 has more merit than T2, then the support would be higher for T1 than T2. It is very obvious, right. The third axiom is a collusive user associated with black market services demonstrates immense topical diversity. What does it mean? So think of a collusive user, right, and a collusive user is the collusive user is compromised by the black market services, and the black market services basically use that account to retweet many other tweets, right. There may not be any topical similarity, it can be any diverse topics, right, sports, entertainment, politics, right, some other events and anything, right, because this account is used by somebody else, this account is not used by the actual user. But if you think of a genuine user like us, right, our topical span is very limited. Say for example, in my case, I generally retweet tweets of some of my favorite movie actor, actresses, or researchers or singers. Sometimes a few retweets based on a few retweets of say some great politicians or philosophers and so on. So my topical interest is very limited, it is not diverse, right. But since collusive users accounts are compromised, right, it can be that account can be used for any purposes. Okay. So, to validate this hypothesis, what we did, for every user, right, we identified the tweets, collected the tweets, and we basically used a a kind of topic detection method, right, LDA or a simple deep learning based method, right, and then using the topic models we get the topics, and we basically get the representation of topics, not the actual topic, and then we plot it in an embedding space. This is a TSNE visualization, 2D visualization. You see that, so these red dots are topical diversity of collusive users and black dots are genuine users. So, you see that red dots are all clustered, meaning their topic sorry, I mean it's the other way around. So, red dots are corresponding to genuine users and black dots correspond to collusive users. So, you see that for genuine users the topics are very clustered, whereas for collusive users topics are scattered all over the place. Okay. We will use these clues for detecting collusive users. Let us now see how to compute the credibility and the merit. Okay. Remember, we already have this bipartite network, right, where you have the credibility of users and merit of a tweet, right, and we have weights, right, and this scores we will determine. Okay. So, to start with, what we do, we assign some seed values to these nodes, both types of nodes, right, and the seed values are obtained from another algorithm called bird nest, right. So, what bird nest does? Bird nest takes a bipartite network, and with each node we also need to provide a feature set, a vector, right, it can be any vector, and then bird nest produces an outlier score for every node, right. So, in our case, for every node, for every user node, we pass the inter support time, right, that set as a feature, and for every tweet we pass an embedding, right, of the particular sentence, the particular tweet, it is a vector. Okay. So, what we will obtain? We will obtain seed score, right, a seed anomaly score, right, something called, say, right, AU and AT, right. Now, since we are interested in the credibility, which is just the opposite of anomaly, so the credibility seed score for a user is basically pi u, which is 1 minus AU, and for tweet pi t 1 minus AT. Okay. So, we will get this pi u is the seed value obtained from the bird score algorithm. Then we also take the sum of all the merit scores of the tweets that the particular user has retweeted. So, for all the outward edges of a particular user u, you take the sum of all the merits, okay, and it is parameterized by this gamma. Okay. So, you have gamma 1 u corresponding to this MT component, you have gamma 2 u corresponding to the bird nest score. Similarly, we also consider the topical diversity of a user. Topical diversity of a user is basically calculated by the cosine similarity of all pairs of tweets that a particular user has retweeted, right. Okay. So, an average cosine similarity, and that is our topical diversity score. It is again parameterized, okay, and then we have another score which is mu u. This mu u is a score that is useful for to avoid cold start problem. So, what is this cold start problem? Cold start problem. So, cold start problem is a very famous limitation, very well known limitation in IR system, information retrieval system. Say for example, there is a relevant web page, right, and there is a query and the web page is relevant to the query, but since the web page is new, assume that the web page is newly created, due to the lack of historical data, number of clicks, right, number of browsing histories for the particular web page, that web page will never come to the top of the ranking. So, this is called a cold start problem. The entity does not have enough history to boost its identity. Okay. So, to avoid this, here also if a user is a credible user, right, due to the less historical information, he or she may not be treated as a credible user. So, therefore, we use another parameter mu u. Now, this mu u is something that we will set empirically, right, and for this component also we have a parameter gamma, right. So, this is some sort of I would say some sort of some sort of smoothing, right, and we normalize it by all the constants, all the parameters and the total out degree. Okay. So, you see here that the credibility of a user is dependent on the merit of a tweet that he has retweeted. Similarly, the merit of a tweet is the sum of all the credible sum of the credibilities of all the users who have retweeted the tweet, right. Okay. Now, remember, this is multiplied by the support, SUT. Support can be WA, right, sorry, WR, WQ, WR is the support for retweet, WQ is the support for quote and so on. Okay. And along with this we have this bird nest score, seed score, and we have the parameter for to address the cold start problem. Okay. And this is normalized by the constants and the in degree. Remember, this is a directed graph, directed bipartite graph, user tweet, right. So, for user this would be out degree, for tweet this would be in degree. Okay. So, now let us look at the algorithm, the CoReRank algorithm. So, CoReRank algorithm starts with an arbitrary value of right, arbitrary initial value of this cold start value mu u and mu t, right, and you also initialize credibility and merit in some ways, right, and then you keep on updating the values of merit and credibility until and unless you see that the change of the values of credibility and merit in two consecutive iterations is less than the threshold, some threshold, right, some threshold epsilon. Now, this is user defined, right, and this indicates the convergence. Think about it, this is completely unsupervised method. Okay. And what you get at the end of the day, we get the credibility score of every user and the merit score of every tweet, right, and then we rank the users based on the credibility, and those users who have less credibility are returned as collusive users, and those tweets which have less merit scores are returned as collusive tweets. Okay. So, if you go through the paper, we also theoretically show that this algorithm has some beautiful properties. For example, this algorithm converges within a bounded number of iterations, right, and we also we also showed that there exist right between two consecutive iterations, the difference between the scores, right, C and M, the difference between the score is again bounded, right. So we proved that Cu at iteration k minus Cu at iteration k minus 1 is basically bounded by 3 by 4 to the power some constant k. Okay. And we also showed empirically that this method outperforms other fraud detection methods, right. And this is kind of the first method for collusive entity detection using an unsupervised method. Okay. So if you want to know more about the collusive activity identification techniques, we also wrote a survey paper, black market driven collusion on online social network. This is available online, so you can go through it and you can get to know about the kind of summary of all the methods that have been proposed so far for collusive entity detection. Okay. So we stop here. In the next lecture, we will discuss another application of network science, which is basically modeling the COVID-19 spread. Okay. Thank you.